This is the red book, yes. Book B for section with the sbarro progettato.
Sorry for the delay. Otherwise, the planner is just finished being quite fun.
Right.
Okay. We don't have the written program. So, oh mio Dio. Yeah. Okay. Here we are. Okay, good. Good afternoon.
Hello, guys.
So we have two of the three virtual speaker. Me, okay. Welcome to the virtual reality and virtual and augmented reality session. I'm so sorry for the delay. Unfortunately, there is very short time between the plenary and the start of the session, and the distance is quite far. So I do not lose more time at the moment. I give the floor to Professor Paolo Nesi, which will present his paper, Design and Develop of a Smart City Digital Twin with 3D Representation and User Interface for What-If Analysis. Please, Professor.
For the introduction.
Very, very good paper, let me say.
Thanks a lot. So, I am presenting the work that we have. I have coordinated in Florence regarding the implementation and the design of the digital twin representation for the purpose of what-if analysis. So the research was included in the context of decision support system with the aim of providing a decision support considering data coming from the field, including sensor, structural information, and all user behavior, traffic flow, and all the other information you may have in the city. There is this huge amount of information. We started with implementing the infrastructure for this decision support since the data from the integration of the basic part of the data in the city. So the idea of digital twin is recently obtained a very strong attention for global and local digital twin. We manage both aspects. So the global aspect of the city with the modeling the infrastructure and all the details that you may have in the city. Including the structural aspect, the informative, the real-time data sensors, the point of interest, the functional aspect and resources, but also implementing artificial intelligence and explainable AI tools for providing prediction, early warning, and integrated with the simulation. So the tool that we have put in place is now available. We are continuing to improve this solution, adding functionalities, and includes obviously virtual representation, as I am going to describe in this paper. As reported in this paper, we analyzed the several requirements. I am not going to explain all of them. That would be very, very long to explain the requirements and to see how the different platform listed here by column satisfy them, yes or no. But it's just for mentioning that you in the paper you may find a formal analysis in terms of requirements and a comparative analysis from what we have done and what is the state of the art in Helsinki, Rotterdam, Berlin, Stockholm, Wellington, and other cities as well. So the main solution is enforced in Snap for City. Snap for City is a platform, as I mentioned before, that we have step by step improved and put in place with the aim of integrating different aspects of the city and also provide the services to the different pillars and to the different services in the city, considering building, energy, mobility and transport, satellite, governance, so on. The platform allows to collect the data, but also to produce the data and to make the representation at a low level and also at a higher level, as will be presented by me in terms of three-dimensional digital twin. The platform is presently quite diffuse in Europe, but also in New Zealand and Australia, China, and also here in Greek, obviously, and South America. So it's quite diffuse. So it's a fully open source, so that someone can download and install without any cost apart from the personnel needed to install it. No license. So the platform manage in the context of the digital twin several different content type that we call a high-level type, that range from the point of interest, IoT devices and mode, geographic information system aspect like orthomaps or GeoTIFF for satellite data, but also traffic flow, trajectories, origin destination matrices, synoptics, and BIM. So all this information integrated together. So I have a small video that describes what is the present status of the 3D representation with the data. You see here some of the pin with the traffic flow data. This video is also accessible the tool is accessible from a web page, but also the video is accessible from YouTube. So you see here the bounding box of the building. You can actually identify them, select them to see the identifier and the other technical elements. You can pass from this representation to a more realistic visual representation, as you may expect to have from an actual digital twin. But it's not limited to this. You can also show the information that you may have regarding traffic or pollutant or others, so heat maps or animation regarding the traffic, and I am going to show you in this view. You can actually do what I have done in this video. You can do it in real time on your personal computer. I think there is no need to have a special tool to do what I have done. So now we are. So what you see is the main railway station in Florence city. And presently I am loading the traffic flow, and the traffic flow is also collected in real time and estimated in real time at what is called a traffic flow reconstruction. So this is the estimation of traffic flow every 20 meters by starting from the data that are collected only by the sensor. This is the effect that and the same can be done for pollutant or others data as well. So the infrastructure is based on, so this is probably a too much technical representation, but what I would like to stress is that if we would like to implement something on top of the platform, what you need to do is only to develop something that is in the area of IoT application and process logic that is marked here as orange. So you need to develop some process for data gathering, for data acquisition, some data analytics, and you may need only to just describe how you would like to represent this and to show this in the user interface. I am going fast. So behind this, there is a knowledge base, so a model to represent each teeny details, a semantic model representing each teeny details regarding the city structure. So each road element, each shape of the building, each information that you have in the building. And you can make semantic query and according to the linked data in the RDF store on which this information is managed. On top of the storage, there are a large number of data analytics that I am not going to read them, that are mainly on, they are close to 19, probably something more, that are focused mainly on mobility and transport, environmental and weather, semantic reasoning, time series, user behavior, and also energy recently, because we have a number of projects on energy management. So for the what-if analysis, we have created this schema for the what-if analysis in which we put together the short-term prediction, long-term prediction to support the what-if analysis, also to simulate what could happen in the city in 3 months or 4 months in advance, or just 15 minutes in advance for traffic. And so this solution can be used for incipient disaster recovery, as well as for planning strategy and tactics in your city. I am not going in deep on this, but there are some paper. This is, for instance, an animation of what I mentioned before for the traffic flow reconstruction in Florence, that we actually compute a new prediction for the next, for the whole traffic flow area that is based on about 30,000 segments every 15 minutes in real time. On the same infrastructure, we do the match from public transport offer and mobility demand of the people according to model that can be called the action-based. This allows us to estimate the number of people that could attend the bus at each time slot of the day, and for each course of each line in the system and in the city. So just to identify which are the most critical bus stops and bus segments in the city. and also with the possibility of blocking, as we see now in these slides, blocking a part of the city with the shape, with the description of the scenarios, and to see what is going to happen in the traffic and how some block in the traffic could create some cascade effects in other part of the city. And also for the routing, with not only for the public transportation, but also for the routing, for pedestrian routing, private routing, or for public transportation routing. So let's go in focus to see how we created a 3D representation. 3D representation has been created compounding and putting together a larger set of resources that came from BIM elements, that are elements of the city, like bench or trees or luminaries or other things like that. Also taking orthomaps for the roof from the geographic information system orthomaps from some view, and also from some LiDAR that could allow us to recover the orientation of the roof, and also images from the facades of the different buildings. And from the catast, we obtained the plant and the shapes of the building, that some of them have been extruded, others have been taken from designer and from the BIM. We also integrated the digital terrain model according to put the building at the specific altitude. Florence is particular, not flat, let's say, and you may know. And so putting together all these aspects with the different insertion of some AI algorithms to avoid doing manually, because manual is too complex and too heavy to be done. And so with all this data, we processed the data and we integrated this data in a unique model in a way that can be fit in a storage and distributed in a real time in a scalable manner. Because one of the problems is not only how to create, but how to actually distribute this huge amount of information that is roughly 80 gigabytes for the Florence downtown. So these are some example of the steps needed to pass from the orthomap, compounding with the building shapes and extracting the roof layers and aligning the roof layers with the shapes and also with the LiDAR orientation of the roofs, and compounding the extruded building with the roof LiDAR with the high value building that have been created by a professional. So the high value building have been created by professionals. So at the end, you have seen the effect of the before. One of the problems is the distribution. So the distribution means that you have to distribute the data at different resolution, and also you have to distribute the right data according to the view that the single user has in its single browser. And this is obviously not a simple job. So for doing that, we have organized the whole information in tile, so of different sides and different layers. And when the view make a request to the server understand which kind of layers, which kind of orientation you have, and so how many layers, at which resolution they are needed, and so the server provide you only so the client can post the right request to receive only the right elements. Otherwise, you risk to have some browser that would need 30 gigabytes of memory to see something. But in reality, with the solution that we set up, you need maximum 3 gigabytes of memory to see it in real time. So you have already seen before the including animation and high available building. Another aspect is that you can do in real time what is called the what-if analysis. For instance, on the right side, you see a part of the city that is blocked with a sort of virtual wall, black wall, and you see in purple the different routing represented without the wall blocking the area and with the wall. So the routing is shown with a 3D wall, a virtual three-dimensional path. So recently we are also moving in the Oculus, and this is something that probably has not been presented in the paper, I think so. And this is we bring the part of our models into the Oculus that allow us to make this virtual trip around the dome. So we are working on this approach to allow navigating in the whole city. Now we have a small part of the city just around the dome to do more or less the same functionality that we have now on the web. If you would like to access to the video, you can go also on YouTube and take it. This is just the first mock-up. So the application is not available in the Oculus marketplace yet. We hope to publish this in September, October, before the Smart City World Expo, at which we are going to present these results. There are some problems, so if you see far from there, you don't see the other part of the city is empty, so there is only this small part around. And just to compile this, it takes 1 day. When you have everything inside, but to have something that can be run in this way, it takes 1 day. You can imagine how many days you needed to have the whole city that I have shown you before. It'd be very complex. So, and we are working on it. So, as you have seen, we have developed the Smart City Digital Twin of Florence. We reported and described the step-by-step all the aspects regarding the 3D collection of the data and the integration of this in the digital twin. Is a very complex process that has to be considered at the system level, considering ingestion, transformation, representation, and the distribution. And it's a very complex to arrive at produces something that can be accessible. Thanks.
Thank you so much. Other questions? Those? I have on the comments. It seems a tremendous giant project.
Yeah, obviously I am just the coordinator, but many people working on it, and only some of them are listed in the first page of the paper, because there are many. So it's a huge work.
Are you using a cloud as a?
Yeah, we have
private cloud or?
We have a private cloud since many years. The DISIT Lab, that I am the chair of the DISIT Lab, we have a personal data center. We have a data center that is quite big, probably is the biggest of the whole University of Florence. So we have, without would not be possible, so we...
Good. Excellent, thank you so much.
So, yeah, if you are interested to work with us, we are growing a lot. For instance, we have now space for 3 new PhD at the same time this year. Just for.
Thank you so much. So, I introduce myself, sorry, because the next talk is mine. I try to recover sometimes. Fantastico, PowerPoint. Ok. Sì, sì, lo schermo. So, are you seeing the screen from remote?
I'm not sure that this presentation is shared in the digital in the Jitsi. Do we have audiences?
Yeah, we are sharing the screen. It seems that the screen is shared.
Oh, okay.
Thank you.
Okay. So, my presentation is entitled Open Metaverse with Open Source. It's quite clear the focus of our work. We are working on open source technology since a long time, and recently the metaverse concept has been attracted a lot of attention because of some big companies are pushing the adoption of the metaverse technology for several aspects like interaction, gaming, and education. This is a long story because open source software in the field of virtual reality and visualization do not has a very good health in the past because often you see that there are some solutions, some technology that appears, get a lot of attraction and suddenly disappear because the reason is that still companies, public administration, and so on do not feel viable to invest in such type of technology. So even if people build up a very interesting tools, then the audience is so is so small that there is no business behind and they disappear. This is really a mess. However, recently there are some tools like Blender that collect a very strong attraction. And the focus of our talk is related to the concept of metaverse because the risk we observe is that, for example, if Meta is pushing a lot against this concept, but Meta developed things with their own technology. So we may found that at the end there is something similar with video games. Video games are killing the open source development of these technologies because they gain so much money that all the market is owned by proprietary technologies. The risk is that if we want to have a virtual environment implemented through metaverse, and we have a different flavor, different technologies behind such metaverse, it's quite difficult, if not impossible, to have, from the user point of view, the possibility of migrating from one platform to another, or the interaction between different type of implementation of this concept. For this reason, we want to stress the importance of open standard and open source software because they are the guarantee respect to a more interactive type of metaverse implemented. The economical pressure is very strong behind the metaverse. One aspect is related to not fungible technologies that are used, properly to give value to digital artifacts. And you know that now there are some soccer players that invested thousands of euros for having their own avatar, and they use this type of investment because they have so much money that probably do not have enough resources to spend. But okay. The other point is that still Meta pushed a lot in order to make the adoption of immersive technologies quite vast. And in fact, they sell several type of hardware with a reasonable cost that can be useful in order to make this type of approach quite extensive in the user scenario. Unfortunately, we have seen already the effect of this process. If you remember, if I remember correctly, more or less 1 year ago, Meta announces for Europe the hiring 50,000 new developers, but after a few months, they announced that 75,000, I guess, in a worldwide basis of developer have been fired. So this is, let me say, a proof of the concept I tried to express before regarding the lack of success on this world in order to have a viable process in this sense. This is the hardware provided by Meta. I don't want to make them publicity, but however, you can see that it's quite rich regarding the past. They offer different devices at a reasonable cost. So this is in favor of the diffusion of metaverse, of course. So, as said before, an open source metaverse and the use of open source standard may facilitate the spread of these technologies in a vast community of users. The metaverse appeared in the first concept appeared in 1992 with the fiction Snow Crash. The idea is that in a virtual world, the human can represent different characters, different beings, human beings, and try to live in a parallel world. For example, making digital avatars of not only of humans, but other type of representation of themselves in the virtual scenario. Of course, we are observing even some problems related to people that stay longer in this virtual environment and risk to lose the contact with the real world. So there are also some issues related to health and to a safe life for people. In our case, we can say that the metaverse concept shows some characteristics that are very, very important. The first is the immersivity, of course. So become very important the adoption of an hardware that enable the user to live immersed in the metaverse. The other is the hyperspatiality. The idea is that in the metaverse, we have the possibility to breaking some barriers that we have in the real world. And for example, has been already implemented in various cases, metaverse where it's much easier to work, especially for people working in the computer science field, because they may have different screens and work in a way that in the physical world is not possible, it's not viable. So can be a very rich experience. The other point is the sustainability, because the economy behind us to facilitate the creation of new digital content and digital innovation in this scenario. The other aspect is the interpolarity. The virtual world user can move freely in any sub-metaverse simultaneously in different scenes. So it's very fundamental to have the possibility of interacting in different metaverses without interrupting the virtual experience. The other point is the scalability. This is, of course, a delicate point because as much user interact in the same metaverse, as larger become the data to simultaneously manage and simultaneously exchange. So this poses some technological issue regarding the cloud, regarding the possibility to have some edge devices that can mitigate the flow towards the cloud in order to mitigate the cost. The other aspect important for the metaverse is the heterogeneity, so that we may have a different type of implementation, different interface and type of data, and we need to communicate in a different way among the various devices the humans use. The application, of course, span in a very vast environment. So from of course, gaming is the most attractive also for company investing in this type of solution because it's a reality that people spend a lot of energies and money in gaming. Important aspects are related to education and training because through virtual reality, using the concept that mirror neurons are able us to learn even in a virtual environment. So we learn seeing things, seeing people acting in a certain way. So the outcome from the virtual, the education and training in a virtual environment can be very significant. Also from a medical point of view, very important. For example, after stroke and similar disease, is very important to have a short time of action between the accident and the recovery technique. So we may implement serious games that can enable people to practice and to recover from the disease much faster. Even because this type of serious games can be played in any situation. So the important thing is that they have a lot of exercise concentrated in a short time, because after this time the recovery become quite impossible. It's important for sport, for example, because it can enrich the training people do in gym or in other contests, architecture and design, etc. So the proposed solution we have is behind our experience, is to use essentially a set of let's say open software in order to implement such environments. I said a sort of open because in reality the main component, which is the video game engine, that is the platform that enabled the programmer to set up the interaction, the movement in the metaverse and so on, has been implemented mainly with Unity or Unreal Engine. Both are not open source. However, they enable people to use their platform for free until the revenue is behind a given value that is approximately 100,000 euros. So in our case, we use those technologies even with students in a course of virtual reality and augmented reality. So it's quite good. But it's not open source. This is important to underline. Instead, Blender, which is the other main component, because we need the video game engine for implementing the interaction, movement, and so on, and we need a good product for building shapes, for building the shapes we are using. Professor Nesi before showed the application of BIM, I saw, so they extensively use BIM technology, and Blender has a plugin which interfaces directly with this standard. So with those two tools, it's easy to implement quite interesting metaverse. We show you some case study we implemented. These are pictures taken from a virtual theater where there is a dancer that can move, and the user can interact with the dancer in the sense that they can alter the movement or change the environment, the lights, and so on. So this part instead is related to metaverse, which are related to the realization of monuments and landscape view. We have seen from Professor Nesi a very extensive application in a city context. In this case, we limited the reconstruction with much poor technologies. This is the case of the fountain in Perugia, our town. The rendering, there are 3 virtual images of the fountain. This has been made using photogrammetry technology. That means we have to take plenty of photo of the structure, and then there is a software that evaluates the vertex of the shape and make the reconstruction using the high quality photos carried out, and the result is quite impressive. However, from the Unity point of view, so the easiest, how easy is to navigate inside this world, the number of vertices is incredibly high. The difference is that in this case, the realism of the shape is quite high, okay? But we pay a price because we have a very high number of vertex, so the rendering is quite consuming in terms of resources. This is another example of still a town close to Perugia, Foligno. This is a famous Palazzo Trinci and the dome, and there is a nice view of the square. It's easy to build up, in this case, a metaverse which mimic a real case of people going to the square, discussing and exchanging ideas. This is another case, some screenshot from living rooms or entertainment facilities. So just to show you the quality is possible to reach using Blender and Unity or Unreal Engine, which are very high quality. Okay, this is the sketch of the infrastructure. So the client connect through the metaverse multiple actors can connect through the metaverse, and the metaverse is implemented using the Photon Unity server. In this case, is referred to Unity. The environment is made by Blender shapes, and the interaction occur through a web server, because in this case we mentioned the infrastructure needed for a chat that can be textual or a voice chat, so people can interact directly, not only because they share the same environment, metaverse environment, but they are able also to exchange content in various ways. So the infrastructure is quite demanding, because there is a web server, database, and then the implemented virtual world using Unity. Okay, so we have finished. So the idea is that the importance of open source and open standard in this context enable user to exchange and having interaction in an open context, respect to closed solution. Thank you. If you have questions, I act content. You have thoughts, questions? Okay. So if no, yeah.
One of the you mentioned before, the difficulties of passing from one platform to another, like Unity
Unreal.
and Unreal. We use Unreal. We discussed it a lot to use one of the others, but it is not clear for us so far the usability and the programming aspect regarding the actual user interface for the control in this kind of platform. I see that you have already done some experience in this case.
Yeah.
You have experience in both cases for the control.
We have experience with Unity. We have some sporadic use of Unreal Engine. However, the products are quite similar, the two products, and the interaction is made using extensively scripts. So you have to the interaction is implemented using C# or similar.
So you can script
You
what
create.
is going to be shown at the user in the virtual environment.
No. The script is related to the interaction. So what happens when the user moves in a certain way, or touch a given surface, or reach a given area. So it's through script that you manage what happens next after the user experience this time. Okay. Thank you. So we can move to the next. The next presenter is Chin Sing Lee. Chin, if you can turn the camera also, okay?
Oh, yes.
And the title of the paper is An Exploration Towards Sustainable Metaverse Systems for Learning by Student Designer, a meta-analysis.
Okay, thank you very much, Professor Osvaldo, and thank you very much also for the opportunity to present in this session. It's much appreciated. I'm from Sami University, Malaysia, which is pretty far away. I think there is an echo. Am I supposed to switch off something?
I close the mic. So.
Okay, so
We close the microphone, so the echo should stop. Okay, thank you.
All right. Okay. So should be okay, right? Okay. I will continue now. Okay. I'm very sorry. I didn't know there will be an echo. Okay. So yes. With
Sorry,
regards to
sorry, Chin. Can you make a presentation mode so that we can have a better view of the slides?
oh
We
okay.
we see only the PowerPoint, the open PowerPoint file, not the presentation. I don't know if you
Yeah.
share the right window.
Oh, you mean to go to slideshow?
Yeah.
Okay. All right. Sorry about that again. Okay. So thank you very much for the opportunity to present. And yes, the previous
We
two
cannot see the
presentations of
screen.
Oswald.
Sorry, we cannot see the screen. You stop the share.
You cannot see. Okay. Let me just share again. Can you see the screen now?
Yes. Okay. Thank you.
All right. Okay. Okay. So the different types of AI. I have much to learn from you, but basically, as what the two professors have mentioned earlier on, will usually be classifier, recommender systems, predictive systems, and also generative systems. So we in Malaysia are a developing country, and therefore we have a little bit of research over here, and also in the recommender systems and predictive systems, but we don't have much in terms of generative systems. So we still have a lot to learn from Italy and also fellow researchers. Okay, as Professor Osvaldo has mentioned earlier on, the metaverse is actually very interconnected, and they are basically atomistic building blocks. So like Lego sets, it's very interesting what the outcome can be from different building blocks. And because they are very loosely coupled, they are also ubiquitous, and therefore usually they will involve the student socially, emotionally, as well as cognitively. So when it comes to a developing country like Malaysia, yeah, so we need to decide if we don't have so much resources in terms of funds and also talents, then what should we focus on? So the whole question of what, how, and also which to focus on is our problem, okay, in the developing country. Okay, so the problem that we want to know is since there are many definitions, and as Professor Osvaldo has also mentioned, there are some successes, there are also a lot of failures. Then what should we actually venture into, right? And then in terms of design thinking, then what should we investigate? So we want to know first and foremost for e-learning what the students want, because they're so used to technology. To them, everything is Valorant, the war games and so on and so forth. And then of course they would be very much into the metaverse even before us. So we want to know how they would want to interact with the metaverse. So the second problem that we want to look into is, since the metaverse is relatively new in Asia, then how can we prepare students in order to develop? Because yeah, they need to have the programming skills, as what the two professors have mentioned earlier on. And then of course besides that, they also need to be very creative, because the metaverse is so huge. How do we develop very lean but very effective and efficient technologies, such as cloud computing, and what kinds of human computer interaction should be in place, so that the infrastructure will be able to afford as well as to interconnect in a very lean way also. Yeah, so we also want to know whether the students will be able to prioritize information flow, because to them a lot of things are just data flow diagrams, but then which particular data flow to optimize, and then how to prioritize this particular information flow when that is something which they would need to learn in terms of design. And then so the next objective is to investigate what student designers and also users perceive as important, because sometimes for us in the developing country, we tend to look at the bigger whole, and then we want to achieve as much as possible. But then, as you know, our resources may not be that much, and therefore we need to know which is more important to which particular market segment. So in that sense, we use three usability questionnaires, which are heuristic evaluation, the computer usability questionnaire, and also the UEQ, which is the user experience questionnaire. So then what we also want to know is whether the students by designing will become more interested in the metaverse, will they become more creative, and also will they become more confident, because a lot of times when the news shouts about the various failures and the various layoffs, and it's like, nah, we are never ever going into that. So, but then if the market becomes a little bit more saturated, then maybe it is something that they would want to further explore. So this is one of the objectives of the study. So I have looked into this one, which is Decentraland and also Sandbox. They are the most popular, and I think everybody knows about this and may even be members. So in Asia, we have Lazada and also Shopee. These are actually e-commerce websites, pretty much like Amazon.com, but with a lot of discounts and vouchers and promotions and sales and so on and so forth. Because Asia, as you know, not every country is rich. Many countries are still emerging economies, and therefore the discounts and vouchers, and the dynamic pricing, all this work well for us. So Lazada and Shopee, they look into the business model in order to shape their focus and also their priorities, and also how to make the architecture more dynamic, and even the algorithms and the parameters more data driven. So in that sense, we look to this because they are the two most popular e-commerce websites in Asia. And then we also noticed that they have a lot of supply chains, and then because of these supply chains, then they are able to provide more value added products and also services, because they collaborate with different countries, and different countries can come and sell their products and also services, and so on and so forth. So in Asia, we just look at them, and then of course we look at the user feedback and also reviews. So again, in Asia, we were looking at, okay, how to make it lean because we don't have much money. Okay, so the metaverse is basically about user experience and also about structure, as the two professors have mentioned earlier on. So if it is about structure, then yeah, a lot of times it's about the SQL and about search, and so are we supposed to be very structured, or are we supposed to be more on the pointer based kind of NoSQL, or are we supposed to be a combination of two? So in this sense, what the first professor have presented, and also Prof. Osvaldo, they have presented a very rich kind of combination when it comes to architecture as well as processes, right? So we actually look at LISP libs because it's very stack based, and to us it's like, okay, still doable because it's a little bit more similar to Python. So, and the young people like Python, so still a little bit more doable. It is not like a huge mountain whereby it's difficult to climb. So when it comes to the user experience, then we were looking at this. So it has to be valuable, useful, findable, and also, of course, it has to be desirable. And then there are three professors who came up with this, who say that, the usefulness part is over here, and then after that, the simulation and novelty part is over here. Then there are another three professors who say that, yeah, actually, the simulation and also the augmentation are the most important part because it will affect the person cognitively, affectively, and also emotionally. Okay, so if that is the case, then we will actually looking at technology acceptance model 1, 2, and 3 are very, very good, but then they can explain only 52 to 67% of the variance. So maybe, okay, if we use the user experience in order to compensate, then we will be able to come up with more holistic kind of understanding with regards to design thinking. So this is where the mapping was done among the 3 questionnaires. And then in terms of methodology, the course which was being studied was a HCI August 2022 semester, and it is a multidisciplinary program course involving the computer science, information technology, software engineering, computer networking, and security students. And so it was not that easy to find common ground except for computer science. So it was still pretty interesting because the computer science people focus more on the architecture, whereas the software engineering people focus more on the processes. So yeah, so basically you see on the right hand side over here, I have to introduce them to metaverse because the news has already put a pretty negative kind of frame to the metaverse. So okay, we went to the Google Trends, and then we look at what is trending, and then we look at a lot of literature review, and that's where we found Italy as one of the utmost and most awesome in terms of sustainable development and a lot of other initiatives. Then we also have feasibility over here, which is to test whether our designs are feasible or not. So there is a SWOT analysis as well as sustainable awareness, chain of effects. So the chain of effects here is pretty important to us because we want to know whether the students are aware of the consequences of their design, or it's just going to be profit, profit, profit only. So besides the chain of effects, I also asked them to prioritize because I wanted to know what their centrality of design is, and then based on that particular centrality of design, then what will be the outcome. So when it came to the assessment, then I used Carnegie Mellon University Systems Analysis and Design rubric and simplify it. And then the ACM Kai Student Design Competition and also simplify it. And then after that, I also use a little bit of design patterns in order to ensure that there's a certain sense of consistency. And then this is a multi-case study meta-analysis, as the title has indicated. And therefore, this is case study 1. And here you can see the respondents' demographics in terms of percentage. So some are from Sunway University, which is the local university, and some are from non-Sunway, still in Malaysia, but nearby universities. So there is a fair distribution in the alpha testing, okay, for respondents who come from non-Sunway, but after that, the students got more students from Sunway itself. So what the students here wanted to do was to come up with a metaverse kind of interconnected e-learning job opportunity kind of system. So I asked them, so what's the difference with LinkedIn? And they say, because everything is integrated. So you have e-learning, then you have the LinkedIn kind of job opportunities. And then after that, you also have e-commerce. So 3 in 1. So to them, 3 in 1 works. That's all that is needed, because for our e-commerce website like Lazada and Shopee, they didn't use AR because they know that our bandwidth in Asia is not that big, and therefore to the students here, they say that if we integrate and then identify what is important for each particular type of system, then that will be pretty good for starters, and then after that slowly build as the ROI comes in. So in terms of the alpha testing, okay, you can see the results over here. Okay, So I will not go through the results, but I will just highlight some key aspects from the findings. So one of the questions was whether the students will become more interested, more confident, and also more creative. So it was good to know that the students for this particular case study actually asked one very novel question, and that is, do you prefer a third party for each of the subsystems, which are education, e-commerce, and also a job recruitment system, or would you prefer an integrated system? So they were really interested to know, whether students would want something which is more decoupled, and but then the students wanted something which is very convenient, all in one kind of thing, and therefore they managed to go beyond the questionnaire, which is more on the testing side, to ask, okay, whether the architecture should be, something which is different. So in that sense, the answer was, yeah, the students actually developed the courage and also the interest to be more, how to say, creative, and also to ask and not just follow whatever questions that I give to them. Okay, so then incidentally, the respondents say that they want to have an integrated system, again because of ERP and because of analytics, and the most important part is because they want convenience. So for the beta testing, you can see over here that they actually made a hypothesis also, okay, and the hypothesis was each topic is inherently different from one another, and therefore a uniform interface and structure for every subject is not viable, but the ease of use is still primary. So they went against the flow, because most of the time we will just say use the design pattern and use the template and don't vary too much. But then to them, because they're all young people, so they say, then it will be a little bit boring. So then they say that, yeah, the uniform interface may not be so suitable, okay, so they want to experiment whether if they vary, then it will be more interesting. So in this sense, the students did manage to make their own assumptions, and they were also trying to experiment with how to design for innovative and also engaging interactions. So the satisfaction increased from 82.4% for ease of use to 88.3%. So this was the first question, 82.4, and then the last question is whether the respondent is satisfied with the system, and you can see over here is 88.3. So that's a bit of an increase, so that's pretty good. And the second highest percentage is 82.4, and this is equally divided between the hedonistic and also the pragmatic. So this actually attests to the mapping to the user experience questionnaire. So what we also found is that by asking all these questions, then the students realize the importance of information clarity as well as feedback. So all these are information related, and therefore it was really good, because I was looking at whether they will use a little bit of information theory or not, and yeah, so they did realize that the information flow is it needs to be pretty compressed. So this was what was interesting, because CSUQ and also UEQ actually have more questions. Say for example, the UEQ has
Can you go to the conclusion, please? Because we are running out of time. Sorry.
yes, yes, Prof. Okay, so yeah, so let me just finish this, if I may. So here we see that they compress the 8 questions and also the 20 odd questions on CSUQ, and to ask these 3 questions. So from here we can see that they are able to identify what was important, and they were also able to model, and they were also able to communicate what is most important. Okay, so in that sense, I go to the second case study. So this is also very stack based, maybe because quite a number of them use iPhone, so they were actually trying to do very modular and stack based kind of pointer based kind of queries and so on and so forth. It was just an experimentation. So the difference between the first case study and also the second case study is in terms of the modularity and also in terms of the centrality of design, because the first one, they were focusing on the individual and the society, and the second one, which is this one, they were focusing more on fun and also from the society to the technology, because they think that this second group think that it is easier to get money or return on investment if they focus on the society and then the technology rather than to focus on the individual and the society. So different orientations because of different backgrounds. Okay, so as Professor Osvaldo has advised, okay, so finally the result is this figure 2A and also figure 2B, and um, the particular green Venn diagram that you see over here, it highlights the importance of disposition as well as expectations, the capability, maturity, and also willingness to accept risk. Because yeah, sometimes some segments of society are pretty rich, but a majority is still a Gaussian curve, and therefore we expect that most likely due to bounded rationality, there will be not much shift unless there are changes in terms of culture or changes in terms of economy. Thank you very much.
Thank you so much. Unfortunately,
Thank you.
we have no time for question. I apologize, but we are running very late.
Yes, I
For
understand, Prof.
my fault, not yours. But, okay, the next speaker is Donato Pera, who will present numerical simulation at 1461 and 1762 San Pio delle Camere L'Aquila earthquake using 3D physics-based model. Please, Donato. Donato, you have the mic muted. So maybe we can revert the presentation if Donato is not ready. We may ask Eder Escobar Gomez to present his paper, that is graphical visualization of phase surface of the Sprott type A system immersed in 4D. Eder, can you present?
Donato, the system told us
Okay.
that your microphone is muted. You should click at the bottom of the screen. You should see a toolbar, and the first button on the left is the microphone button. So you should click the microphone button on the toolbar in order to open your microphone. Otherwise, we can't hear you. Donato, can you try to refresh the web page or change your browser? For instance, try to use Chrome or Firefox.
No, fai continuare, devo fare.
Okay.
Devo fare. Eder, in the meantime that Donato try to solve the technical problem, can you? Donato is returned. Okay. Let's see.
Microfono acceso. Okay, Donato, can you hear us?
It seems that
Donato has some technical issue. So, please, Heather, can you share your screen in order to start your presentation?
and unmute the microphone.
Heather, can you hear us?
Can you write in chat message? Is the chat is the
Questa devo staccare la tua.
sì, grazie.
Negative, Donato. I cannot hear you. Maybe I try to refresh the page. Just a moment. Donato, can you try to speak now? But yes, but the system. Okay, Donato, can you hear us? We cannot hear you. At the bottom, using the toolbar, if you click on the icon with 3 little dots, you should see an option, the settings options. So here, let me just share the screen in order to help you. So please watch the screen that I am sharing. If you look at the bottom, you should see a toolbar with 3 little dots. If you click and click settings, a new window should pop up in the middle of the screen. At the bottom of the window, there is a slider that moves, indicating that the microphone is functioning in a correct way. So for instance, in this case, the slider is moving because I'm speaking and the microphone is recognizing the voice. And also you have an option called play a test sound to test your speakers. So please check if the microphone is correctly recognized by your system. Yes, Eder, if you can unmute your system and speak, we will be happy to view your presentation. If you have a connection problem with your main system, you can also join the meeting using your mobile phone. If you want to try, please open the room with your mobile phone and try to join the room with your phone. Eder, yes, you can start your presentation, but in order to start your presentation, you must unmute your system because otherwise we cannot hear you. Heather, can you hear me? Yes, but we have just two presentation because Donato Pera and Eder are the last. We have no other presentation to do, just Eder and Donato. So I'm sorry about that, but can you try to join the meeting with your mobile phone? Donato gets some troubles, and I don't know if he can hear me. And also, Eder is not answering me. He just continue to ask me.
So I
Okay, Donato, we can see you.
so I so I'm using the main problem is that so the main problem is, can you hear me now? Yes, sir.
Sorry, Donato, we can hear you, but seems that your audio is too loud.
Okay, maybe now is better.
Better now. Yeah.
Okay. Sorry, I have to use two devices. It seems because I don't know why I changed also the browser, but from the computer the audio is not possible to use, and I think that there will have similar problems. Anyway,
Okay.
don't worry, we will continue in this way. Let
Yes,
me share my
please,
screen.
you can
You can share
you
the
can
screen.
share or talk about your presentation if you are unable to share.
Yeah. Okay, you should be able to see my screen now, or I hope so.
I guess yes.
Is readable?
We are not able to see your screen because probably there are some issue in the probably a firewall is blocking some ports, I think, in your network. But if
Okay, I will try from the other one.
okay.
Now? Are you able to read my screen now?
No, we doesn't see any presentation, but I think that you can describe your presentation and it's okay for us. You can just talk about your paper and take your time if you want.
Yeah. Okay, let me try just one time because and plenty of figures and I think it should be nice
I
to...
think that the problem is probably because some ports are blocked by a firewall in your network. So, in order to fix easily the problem, you should try with a mobile connection using an hotspot to avoid the Wi-Fi that probably you are using. But I
Okay, one moment. I will try to change also the connection, but I think...
yes,
okay.
if you want to try that.
Yeah. Let me refresh. Okay, now are you able to see?
Now we are able to see your screen. Now we see everything, so you can proceed. Thank you.
Okay.
So please, can you just mute one of the users that you have connected in the virtual
Yeah.
room? Because otherwise there is a very
Okay, good.
strong echo.
Good.
Okay, thank you.
Okay, Damiano, sorry for this. I will try again. Can you hear me?
Yes, we can hear you.
So I will try to share with you my screen for the last time.
Okay.
Okay.
We can yes, we are seeing the screen correctly.
Okay. Sorry, I changed at least 3 browsers, and but it seems I still have problem. Maybe anyway, I am at university, so I don't know why. Very sorry for this. So I will start with my presentation. So today we'll talk together about this numerical simulation of the 1461 and 1762 earthquakes that happened in San Pio delle Camere, that is a small village near L'Aquila. So, first of all, to main question, why to study earthquakes? We study earthquakes because essentially are quite dangerous and able to generate victims, injuries, and homeless people. During earthquakes, it's also possible, we know very well here in L'Aquila, it's possible to have serious damage to buildings and infrastructures. The second question, quite important, is this. So, we can ask to us, is possible to predict in such way an earthquake? No. The main answer to this question is no. It's not possible at the moment with the knowledge that we have on science to predict earthquakes. But what is possible to study the potential effects of an earthquake using PBS APC simulation, so physical based simulation together with high-performance computing techniques, and also machine learning tools. And this is exactly what we do in our paper. So, first of all, we have to define which is the answer that we want to do to the definition of seismic risks. So, when we talk about earthquakes, it's quite important to estimate in such a way the seismic risk related to an earthquake. So, to do this, it's important to analyze 3 main parameters that are the seismic hazard, the seismic vulnerability, and exposure. So the seismic hazard is related to the estimation from a physical point of view of the shaking effects that could happen at soil level during an earthquake. To estimate this parameter, we use, or in general, geologists and seismologists use some physical parameters that are the peak ground acceleration, the peak ground velocity, or the permanent displacement. The second parameter that is quite useful for the estimation of the seismic risk is the seismic vulnerability. For the seismic vulnerability, we mean essentially all the effect that could happen on civil infrastructures and buildings during an earthquake. And finally, we have the exposure. So with exposure, we try to quantify how many structures, people, and buildings could be damaged from an earthquake. So the first parameter, the seismic hazard, is quite related to the physics words. The second one to the civil engineering, and the exposure is essentially related to several disciplines, such as economy or civil engineering, and so on. We work mainly on the seismic hazard. So all the contents of our paper is related to this aspect of the seismic risk. So what we normally do, essentially, we start considering an elastodynamic equation, and we use this kind of mathematical problem to simulate essentially the behavior of an earthquake. In the formula number 1, you can find the general shape of the momentum equation, and in the equation number 2, you will find a general relation for the stress and strain. Combining these two equations, we go directly to the equation number 3, that is essentially the general formulation for the momentum equation. So what we normally do is consider the Lamé parameter, that are the parameters that will describe the properties of the soil level, constant according to some specific hypothesis. So we will reduce everything to the study of the equation number 4, because under this hypothesis we will erase from the equation number 3 the first two terms, because for us the gradient of the two Lamé parameters lambda and mu will be equal to 0. So starting from the equation 4 and using HPC technique, discontinuous Galerkin methods, and in particular one software based on these two techniques that is named SPEED, provided by the Politecnico di Milano, we compute some simulation related to the mentioned the earthquake that we mentioned above. So, which is the target area related to our study? So we consider an area, a rectangular area with a side of something like 70 kilometers times 59 kilometers around the city of L'Aquila. In the gray area, we will consider the bedrock, so the harder parts of the external crust of the earth, and the central part where we have color is essentially the alluvional basin based around the city of L'Aquila. Why we have to consider these two zones? Because essentially the mechanical properties of the two areas are quite different, and in general when we have to deal with physical-based simulation, it's quite common to introduce a general model for the bedrock and another specific model with some specific laws that will describe better the alluvial basin, that is the most important area to study to consider the transmission of the seismic waves. The two earthquakes that are studied in this paper are essentially located, we have the estimation of the epicenters provided by NGV, under these two red stars. So the first one will be the earthquake happened in 1461. Instead, the second one is the earthquake happened in the 1762. So what we have to do, or what we design to introduce this data inside our supercomputer, we design a Python tool to reconstruct in such way a digital twin of the piece of the art that we want to consider for our simulation. So to create our domain, first of all, with our Python tool, we reconstruct the external surface of the art using a topographic map. After this, the step number 2, starting from this external surface, is to define a cake layer model. So we consider this external this topographic map. Starting from this topographic map, we define a model with a depth equal to something like 20 kilometers. So we will have what you see in the step number 1 on the top of our model, and starting from this, we go down in Z direction for 20 kilometers. So it's possible to appreciate the several layers that we consider in the figure defined in the step number 4. So you can see that we have this external crust that is represented in green, and after this you will appreciate several other, at least other 2 layers, one brown and another in light brown. So this is the final product that we will consider. We have one step more, so we don't consider only the cake layer model of this piece of the external crust, but we'll introduce also a reconstruction of the faults that we want to study for the simulation of our earthquake. So in the step number 3, always retrieving data from NGV studies, we are able to reconstruct in such way the fault plane interested for the generation of the earthquake. And finally, in the step number 4, we combine the two models that we get in the step number 2 and in the step number 3. And the final product will be exactly what you see in the step number 4. So essentially, you will have the cake layer model with inside the fault that we want to study. So for this particular paper, we reconstructed something similar to you have seen in the previous slide. And essentially, this is the model reconstructed for the two earthquakes happened in San Pio. So we have a size of the domain with a length equal to 67.2 kilometers. The other side is equal to 59.7 kilometers, and we have a depth of 20.1 kilometers. This area highlighted in red is essentially the projection of the fault plane on the top surface. According to what we are able to appreciate in the step number 4, the fault plane will be inside the studied domain. So in this figure, we highlighted this area in the top surface using the color red. But anyway, for the physical simulation, you have to consider the fault reconstruction inside the domain according to the geological data. What about the dimension of the fault for the studied area? For this studied earthquake, we have a length of the fault equal to 16.2 kilometers and a weight of 10.5 kilometers. After this, you can appreciate also the strike, dip, and rake that will define the physical location, the geometrical, physical, and geometrical location of the fault inside our domain. So this triangle essentially will define the spatial orientation of the fault inside the computational domain. Starting from this model, we will define on the fault plane, so essentially along this red area, some slip distributions that will be essentially the initial condition that we have to consider for the simulation of an earthquake. It's not possible, according to the historical data, to reconstruct exactly the original slip distribution along the fault for the two earthquakes, but in such way, using the location of the epicenter, is possible to reconstruct some hypothetical scenarios that could be used for the simulation of the earthquake. We consider in particular 3 hypothetical scenarios for the slip distributions that you will find on the top, in this top that we have, in this figure that you have in the top for the earthquake happened in the 1461. So you will have the scenario 1, the scenario 2, and the scenario 3. And in the same way, we reconstructed 3 hypothetical slip distribution for the second earthquake, so the 1762. So you essentially, in our paper, we consider 6 different simulations, where the first 3 are related to the earthquake happened in the 1461, and the other 3 are related to the second earthquake. So starting from these ideas, so just going back from this computational model and this initial condition, we run several simulations using some specific parameters. So if we go back, in particular in this figure here, we said before that in such way you have to define some specific parameters for each considered layer that we define inside our cake layer model. So the parameter that we normally consider will be reported in this table, and in particular we'll describe the mechanical properties of our crustal layer, and we discover also the depth related to each layer. In particular, for this model, we consider 4 layers, so 4 cut in the previous figure, just to be more clear, where the first layer will have a depth of 1 kilometers, the second one also 1 kilometers, the third one will have a depth equal to 3 kilometers, from 2 to 5 kilometers of depth, and the final one will have a depth of 15 kilometers. For each of these layers, we consider essentially some mechanical properties, some specific parameters to describe everything according to the geophysical data. So for each, we define the VS velocity, the VP velocity, the rho, and the quality factor for the shear waves. Essentially, these parameters are quite important to characterize properly each layer and to reproduce in such a way the right behavior of the seismic waves inside our domain. Running the simulation, we get some result, and we plot the results using the PGV map. What we mean for PGV map? For PGV, we mean the peak ground velocities. So essentially, we plot all the velocities inside the considered domain, and we consider the peak velocity related to some specific points. So we got the maximum values around this area that is not so far from the real location of the village of San Pio delle Camere. This PG map is related to the first event. This second map is related to the second event. Also in this case, we got a peak of PGV around the area of the real position of the city, the village of San Pio delle Camere. The final step is to move from the physical parameters to some parameters able to validate in such a way our data. So we have some physical based simulation. What we have to do is compare in such a way these data that we are able to produce with the historical data that are the only data available from the literature related to historical earthquakes. It's possible to do this using some specific models that are able to link in such way the peak ground velocity that we show in the previous page with the macroseismic intensities. So the macroseismic intensities are essentially the values related to the produced or the not produced, sorry, the estimated value of Mercalli scale, so that are available in the literature. So essentially, if you try to read the literature related to historical earthquake, the only data that you will find will be the value related to the Mercalli scale, that in such way will describe the effects of the earthquake in the villages that were damaged from the seismic events. So we can starting from this idea, we produce other two maps to compare in such way our simulated data with the historical data that are available from the literature. So according to this, we produce these two maps. The first is for the seismic event happened in 1762. Sorry, there is a mistake. The first is the 1461. The second one is the 1762. So we have some specific data, maybe from the map is not completely clear which are our results, but we can read together the table. So we consider some specific locations that are available from the historical data, that are some villages around the San Pio delle Camere village. And in particular, we consider Onna, Sant'Esanio Forconese, Castelnuovo, Castelvecchio Calvisio, L'Aquila, and Poggio Picenze. So in this final table, we have the epicentral distance, so the distance of these villages from the epicenter, and everything are inside the range between 5.5 kilometers and 13 kilometers for this first seismic event. After this, we compare the simulated macroseismic intensities with the macroseismic intensities provided by the literature. So in this first column, you will find the estimated macroseismic intensities that you can find in historical literature, and in these three columns named as IMCS SC1, IMCS SC2, and IMCS SC3, the simulated values for these macroseismic intensities. In the last final three columns, you will find an estimation of the error for each location. We did something similar also for the second event. We consider retrieving the data always from historical literature, these five villages that are Castelnuovo, Poggio Picenze, L'Aquila, Barisciano, and San Demetrio de Vestini. In this case, the epicentral distance will range between 2.1 kilometers and 16.4 kilometers. And also here we compare the historical data with the simulated data. So in this table, you will find essentially in this first column the historical estimation of the macroseismic intensities in these locations. And in these three columns, you will have our simulated data. What we got at the end, we can read together this final table. Essentially, we got a good agreement for the first computational first simulation that we performed related to the earthquake happened in 1461, and not a so good agreement for the second event. We can justify the results saying that for the second events are not, also if it's more recent, we don't have a lot of data to compare exactly the simulated data with the real data, and also the estimation of the epicenter is not so clear compared to the first case. These simulations are part of a larger project that I can show to you. In particular, in this web page, you can find a collection of simulation, all based around the L'Aquila area. Just one moment, I'm uploading the data. And if you scroll this menu, I hope that is readable, you can select several earthquakes with three distinct epicenters according to the default that we consider for the simulation of the earthquake. In particular, you can consider the Monte Reale fault with a magnitude that would range from 5.5 to 6.5. After this, you can consider the Paganica fault, that is the owner of the most recent earthquakes that we had in L'Aquila in 2009, and finally also the San Pio fault. The simulation that we have on these sites are not exactly the same that we produce for the historical earthquake, but is something similar, and we hope that we'll upload this historical data in this web page in the next days. So essentially, if we select San Pio for ISTID, what we can do, you will have a simulation of the propagation of the seismic waves inside the study domain that is essentially is based on the city of L'Aquila. The dimension of the considered domain are quite similar to what I showed in the previous case for our historical simulation. And all these dots that you have on the screen are essentially the roof of the main buildings that you can find in this area. For each building, clicking on it, you can read at the soil level the values of the displacement, the acceleration, and the velocity. Always consider at the soil level. We don't consider in our study, we are not civil engineer, I'm a mathematician, so we consider just what happened under the building. So we don't have the response of the buildings according to the seismic waves that we are able to simulate. Anyway, we have this information at soil level that could be useful for civil protection and civil engineers. It's possible also to distinguish among the components of each parameters that we are able to estimate, and in particular you can consider the x, y, and z values related to each parameter. If you mark these three, by default you will get the modulus of each quantity. Okay, very sorry for the technical problems. I hope that at the end, anyway, we solved everything.
Thank you so much. Thank you so much, Donato.
Yeah.
Okay. Unfortunately, we are running very, very late. So I guess the other author is not.
Let me check.
Any more connected? No. Okay. So we close the session. Thank you, Donato. See you.
Thanks.
Bye-bye.
I'm very sorry for this.
Thank you for attending, for your
Thank you.
patience.
Bye.
Bye-bye.
Bye.
Vieni un minuto che io sto chiudendo tutto. Un secondo.